Good evening. Thank you very much for coming in this evening. On behalf of the Roads and Transportation Society, you're all very welcome here tonight. We're delighted to present Capri by George Lunt from AECOM, which is Understanding the Technological User and Commercial Requirements for Autonomous Pods. George is a technical director at AECOM with 17 years experience in the transport industry with a strong background in transport data, analytics and modelling. He's been fortunate to be involved in the design and delivery of practical transport systems, including Cardiff's new bus station, M50 VSL around Dublin, and community permeability schemes in South Dublin. As project manager for Capri, George is leading a consortium of 19 project partners, ensuring a wide range of technical work streams to integrate to deliver public trials in 2019 and 2020. So I'll pass you over now to George. Thank you.
Okay. Thank you very much. Good evening, everybody. And yeah, it's a pleasure to be here. Thanks very much for having me. Can you all hear me okay? Is that all right? I'm hopefully loud enough. Thank you very much. Okay, yeah, thank you very much for the introduction. Yes, I'm going to be talking about the Capri project, which we're involved in the UK, and also a bit of an introduction to connected and autonomous vehicles as well. I thought before starting and sort of getting into the presentation proper, it would be interesting just to get an understanding of people in the room, sort of people's current understanding of connected autonomous vehicles, particularly on the autonomous side. So maybe put your hands up if you're fully understanding of autonomous vehicles as they are today. Oh, we got one hand. That's oh, we got two. We've got two hands up. That's a good sign. People perhaps involved in it in a little bit, or perhaps on a personal basis and things like that. People who understand a little bit about it. Show your hands. Yeah, a few more. So perhaps 4 or 5. People who know nothing about it at all. Put your hand up. Okay, 1 or 2. So we've got quite a good spread. That's good to see. Next poll. Just people who sort of think that autonomous vehicles are going to be a wonderful thing and really provide benefits to us in the future. Doing a quick show of hands. Okay, probably the biggest lot so far. So we've got sort of 6 or 7 there. People sort of umming and ahhing, not too sure what the benefits are going to be. Perhaps some disbenefits as well. Yeah, a few more, 5 or 6. People think it's the worst thing that's going to happen to us ever. No people. Okay, right, good. So maybe not too much heckling. That gives me a good understanding. Yeah, thank you very much. Okay. In terms of what I'm going to talk about tonight, I'll start off brief introduction about myself and I guess, excuse the pun, the transport journey that I've taken in order to where I am now, managing a CAV project. I'll then give an overview of connected and autonomous vehicles as I see it, and from what I've experienced really over the last year, a bit more of a year involved in the Capri project, where things are currently in the CAV marketplace. I'll then talk specifically about the Capri project that AECOM's involved in and that I'm leading, how it's come about, and some of the technology and research that we're undertaking on the project, and some of our current findings that we've established so far. I'll then talk a little bit about preparing for CAVs. This seems to be quite a burning question, particularly for us as engineers trying to design and plan the future of infrastructure. People often talk about CAVs we're at a sort of a current point or a turning point in time. People are all saying we're in a massive state of change, but actually that's not terribly helpful if you can't actually plan for that and help plan for the future. I'm not going to have all the answers, maybe not even some answers, but I'll try and give some of my thoughts as to how we can plan for that. And then finally sum up with summary and final thoughts. Okay, just a brief introduction to myself in terms of the transport journey that I've taken. Started off at Exeter University and did a degree in mathematics, then did an MSc at Bristol University, and then I worked for 6 years at the Transport Research Laboratory in the UK, mainly focusing on motorway control and traffic modelling. And then I've now been at AECOM for probably about 11 years now, and sort of taking some of that motorway control and modelling experience that I had at TRL and using that in more sort of the local applications, doing traffic modelling, microsimulation modelling, but also taking some of that knowledge of the motorway control aspects that I picked up previously and applying that in a different way at AECOM, which was nice to be able to build upon that and take it forward. And then getting more involved in team building and leadership roles. And then I got landed with an autonomous vehicle project, which sort of came out of the blue to some extent. But I've really been able to use my previous experience and things that I've been able to pick up to be able to lead the Capri project. So I'm calling it more of an unexpected journey in terms of, if I could tell you 15 years ago that I'd be here working on autonomous vehicle projects, I wouldn't be able to say that. But I'm very, very glad to have been able to be working on it over the last year. Okay, an introduction to connected and autonomous vehicles. I've got a video here. It probably lasts about 3 minutes or so, just to give an overview. This isn't a Capri specific video. It's one that I've taken from the web, but I think it gives a nice summary of where things might be.
Our city has grown up pretty much like all the other cities, and it constantly changes. We become more people, the city grows, we build houses, more roads and parking lots, more vehicles. But human beings also need space. So what would happen if we drive away the cars of today and start using autonomous cars instead? Autonomous cars don't need any signs, and autonomous cars need less space, enabling wider sidewalks. It creates more space for us humans. And autonomous cars can drive and park themselves somewhere else. Look at this commuter station. You will be picked up as soon as you leave the train, because autonomous cars know when you arrive. So this reduces waiting times, less pressure, less stress, and autonomous cars will take you all the way home. Check out these autonomous trucks. They're driving close to each other because they automatically line up into road trains. This saves loads of energy for transport, and that is good for all of us. And since the autonomous vehicles communicate their arrival times with their destination, the loading and unloading can go so much smoother. And when the trucks don't have to stand and wait, can use their parking lots for other things. Look at the front of the shopping mall. It's just a lot of parking lots. We would not need all of them anymore. We could do something funny. It could be a park instead, with an outdoor swimming pool and a cinema. This is a place to live in. So with autonomous cars, more space is created around the needs of people. Cities become nicer and more beautiful. Streets become safer, travel smoother, less noisy, more space for life. Well, it will be better.
Okay. What do you think about that? Does that make you think, wow, this is going to be the future, isn't it? Isn't it absolutely wonderful? The reason I like that video is because, well, it gives one view of the world, I suppose, under autonomous vehicles, and it touches on a few key parts, like, well, the autonomy side of things, the connectivity, the land use, some of all these different benefits. But in my view, it certainly puts it through sort of rose-tinted spectacles and sets out, well, this is what the future could look like. And really, through the Capri projects and what we're trying to understand some of the practical implications of these things, and importantly, how do we actually achieve some of the benefits that are being reported here, rather than it isn't just going to happen through sort of osmosis and these things happening naturally. A brief overview of connected and autonomous vehicles themselves. You can see them in all sorts of weird and wonderful different guises. Some of you may have seen some trials which are perhaps reported in the media. On the streets of Dublin themselves, I think Navia themselves have had some trials locally as well. And our Capri pod is here. It might look a bit strange on its own, but then when you see it with all the other autonomous vehicles around as well, it certainly doesn't look out of place. I think importantly, there's different kinds of autonomous vehicles. Some of them are sort of retrofitted in terms of a standard vehicle. So these might be ones more on the bottom right, or the Waymo one in the middle towards the bottom. These vehicles will generally come from a safety base, in that those vehicles have already been crash tested, and then the sensing and control parts are then retrofitted on top of those. And some of those may actually have a steering wheel inbuilt in there. And actually, when the vehicle's being driven autonomously, you'll see the steering wheel drive, because the autonomy is within the drivetrain itself, within the vehicle. Whereas some of the newer vehicles which have been developed and manufactured have no steering wheel whatsoever. The Capri pod is one of those, as well as some of the other ones. So these vehicles have been ready-made for autonomy. They're not being retrofitted with different sensors. They're being built with autonomy in mind right from the beginning. I think it's important when thinking about connected autonomous vehicles to think of the different aspects that the technology leads to and provides within these vehicles. Often when these things are talked about, they're actually confusing lots of the different elements of future technology parts which are coming into vehicles. The first one is that these vehicles are autonomous. Like I've said some of them do have a steering wheel in there, and a driver might be able to take control of the vehicle at certain times. I'll come on to that in a minute. But principally, the vehicles are driving themselves, and they have sensors built into the vehicles so that they can see the world around them, and importantly, they know where they think they should be within that environment as well. So that's the first thing. They are autonomous vehicles. Second one is that these vehicles are connected as well, and often you talk about CAV in one, CAV, connected and autonomous vehicles. You talk about these in the same breath, but actually they're very, very different aspects of future technology and the impact that these things will have. Connected vehicles are vehicles which are perhaps connected to each other. They're talking and communicating to each other. They might be connected to the infrastructure around them as well, and the infrastructure might be talking to them. Some of these things are happening already, but in terms of how the technology can develop further, there's tremendous potential for additional connectivity within vehicles, and also connected not just to other vehicles and the infrastructure, but to the people as well. So the vehicles might be connected to people that might be hailing the autonomous vehicle, or they might be actually connected to people within the vehicle, within the pod, providing an enhanced experience to those people in there. Thirdly, lots of these vehicles are electric. I mean, this is the way lots of the vehicle fleet's going, a move gradually from petrol to diesel over to electric vehicles. And we're really seeing, in terms of the technology uptake, probably the electric part, we're seeing that very much now on a practical basis on our streets. In terms of the actual range anxiety seems to be coming down. And all of these autonomous vehicles which are being trialled and tested all have, or the vast majority of them have an electric, are electrically powered. And the fourth part here is less about the technology on the vehicle, but some of the enabling technology which might allow a different way that these services are provided to users of transport. And principally, this is the idea of shared ownership of vehicles. So rather than owning a vehicle in its own right for yourself, then vehicles might be shared or pooled. And again, we're seeing this being used more frequently, and the uptake of these is happening quite rapidly, particularly in busy city centres. And then shared trips as well. So rather than having a vehicle for your own or your friend, then you might be able to pay a reduced fee and share a trip with perhaps an unknown person. And this is all these various different elements here are coming into the mobility as a service and the drive that's going towards that. So basically moving over to a shared vehicle ownership model rather than a private ownership model. And fifthly, and most importantly, is people as well. So people are at the heart of this, and it's important not just to think about the technology, but all of these things need to enable and support and enhance the person experience and the benefits that they will get from connected and autonomous vehicles. So that's 5 key elements that are important to distinguish apart from each other. In terms of the key benefits, the first one is safety. And this has been reported lots in terms of the development and the research funding which is going in. There's a famous statistic around 90% of accidents are caused by human error. And if these vehicles are autonomous, then in theory, you can in theory have a safer transport system and the accidents could be reduced. That's one of the stated or proposed benefits of autonomous. That's particularly linked to the autonomous vehicles. Some of the connected vehicles as well can help improve safety as well. Second one is congestion. Less so on the automated side potentially, but maybe if the vehicles are driving closer together. But in terms of the coordination of vehicles in a city centre, or the preemptive nature of understanding what trips people might want to take, and the more efficient transport network, CAVs could in theory improve congestion within our road network as well. Productivity in terms of automated vehicles, people who are driving manually, that's the task that they're doing when they're in the car. If they're no longer driving, then they have much more time on their hands, and so in theory they can be far more productive, whether that's from a work point of view or a social point of view or a relaxing point of view. But in theory, time can be sort of pulled back and used for other things as a result of automation. Fourth one potentially is the environment. And this is perhaps more linked to the electric vehicle side of things, putting aside the carbon emissions, but in terms of the NOx and the PM10 emissions that come out from our standard diesel and petrol vehicles, then potentially there'll be improvements to the environment, and linking with some of the improvements to congestion as well. Some of these things all go hand in hand, but they're not necessarily one technology part which will improve that one. They're all interrelated. The fifth one is mobility. Again, lots of people aren't able to drive or are restricted in terms of how they can drive, when they can drive. Young people, old people, people who aren't able to have a driving license. So autonomous vehicles can radically change the accessibility for those who can't currently drive vehicles, and that, from a social point of view, can have real benefits in the future. One of them is cost. In terms of public transport, about 40% of the operational cost of buses, for example, is on the bus driver. So from a public transport point of view or from a taxi point of view, if that cost is taken out and the vehicles are fully autonomous, then in theory some of the costs could be brought down, again improving accessibility to these kinds of transport interventions. And the final one there, we saw it in the video with the car park being rolled up and turned into a swimming pool and a cinema and so on. But if the vehicles are driving autonomously, then the requirement for car parks in city centres could potentially be reduced. Vehicles, again, linked more to the sort of the shared and the rented aspect of vehicles. Once you've taken your trip, that vehicle can then move on and then serve another purpose. So the potential use of car parks in city centres and other areas could radically change as well, and then the land use requirements and way that the redevelopment could happen could be improved as well. So that's 7 potential benefits which are reported amongst governments, within the media, within various researchers as well. I think it's important to think that some of these benefits, we're not actually sure whether they will be benefits, and actually when you try and flip it around the other way, sometimes you might think that it might have the opposite impact. For example, safety. A few people were umming and ahhing when we first had the poll at the beginning. I mean, if the autonomous vehicles aren't safe and they're rolled out across the world, then what kind of impact will that have on our safety record? 90% of drivers, 90% of accidents are caused by human error, but what kind of new errors might be introduced as a result of autonomous vehicles if they're not done safely? Cybersecurity attacks, for example, either on the vehicle itself or in some of the cloud, and where some of the communications happening could have detrimental effects as well. So that's an important part to consider as part of the paradigm. From a congestion point of view, we talked about easier access to the transport system. then potentially more people could be travelling. So potentially more vehicles on the road, congestion may actually start going up. And you can sort of flip lots of these different parts on their head. The cost, the assumption is you take the driver out, then the cost will immediately reduce. But actually some of the operational costs and things behind the scenes that might need to happen with autonomous vehicles, simple things just like maintaining the sensor sets, keeping the cars washed and clean and effective, is a big part that needs to be considered, which is a new cost, or a new additional cost, which perhaps isn't so costly at the moment with manual drivers. So all these different things need thinking about and understanding when we're doing the research and working on the various projects. Okay, levels of autonomy. Who's familiar with levels of autonomy in terms of automation in vehicles? Okay, a few people. I'll just touch on this briefly, but the scale goes from the left to the right in terms of vehicles which are not very autonomous, if you like, in terms of level 0, all the way up to level 5, which is absolute full autonomy. I'll just touch on these briefly, but these first 3 levels is the way that some of the vehicle fleet is moving at the moment in terms of assisted braking. Some of the examples are down here. So some vehicles currently have lane departure warnings. For example, when you're driving on the motorway, it might give you a warning. But critically, you are still driving the vehicle in these 3 levels, level 0, level 1 and level 2. You are always in control of the vehicle, but you might be given cues or information from the autonomous part of the vehicle, which is telling you, by the way, you need to think about this, you need to think about that. Similarly, some of the adaptive cruise control and the lane centering, some of the things which might aid a driver, is part of level 2. But importantly, the driver is always in control of the vehicle. That's the blue section. Then we start moving over to the interesting parts, level 3, level 4, and level 5. This is where the driver at times can just take the hand off the steering wheel and the vehicle will be driving for you. Level 3 is a situation where you can take your hands off the steering wheel, but the vehicle might tell you at a certain point, you need to start driving now, in which case you might have been just, I don't know, talking to someone or something like that, and then suddenly, because the vehicle's got into a situation where it can't cope or it can't behave, then you need to then suddenly start taking the steering wheel and driving. Some people think that actually level 3 probably will never happen in the long term because of the safety implications of lots of research showing that if you suddenly have to start concentrating on the vehicle, it's very, very hard. It can take up to about 10 seconds or so to actually fully understand what there is around it and be able to drive safely. So even though some of the testing at the moment is really happening at level 3, there's always a test driver and they're able to take control at any time. Some of these instances have been well reported in the media in terms of that safety driver not taking control at the right time. But it's expected that probably level 3 will be leapfrogged and then move to level 4. Level 4 is a situation where the drivers will not have to drive, and actually the vehicles may not even have a steering wheel in them, for example. However, level 4, the vehicle will only operate within a certain what's called operational design domain. So this is the vehicle is only programmed and understands to operate within a certain geography. For example, on a business park, on a bus route, for example, and if it goes anywhere else, then it won't know what to do and it won't drive. And I guess that operational design domain can be as narrow or as broad as you like, but importantly, it does have boundaries. And then the final point in time is level 5, where the vehicles are fully autonomous and they can go absolutely anywhere. I think this is probably a point in time way in the future. I imagine even in sort of 100 years' time, there will still be boundaries to what the autonomous vehicle knows it can do, and then it might just stop down to a safe stop or something. But that gives an overview as to these levels of autonomy. I said the focus of the Capri project and lots of the projects at the moment is looking at level 4 in different operational design domains. In terms of CAV time horizons, this is some research that's been done by the Transport Systems Catapult in the UK, looking at different uptakes of CAV at different levels, principally level 3 and level 4 and 5, we just talked about on the previous slide, under different scenarios in terms of a high uptake, which is the dark purple and pink on these two here, sort of middling uptake, a low uptake, and then a very low uptake of CAVs. And the percentage here is the percentage of sales of CAVs within this particular category. So you can see, sort of starting off, where are we now? We're up to almost 2019 now. Some of these predictions you can see are probably quite high at the time, but then this is government research, and which has been put out, and these are the timelines which we're working to at the moment. Sometimes you might find with technology that you might have a projection which is quite steady, but then with rapid technology uptake, it might take a bit of time, but then suddenly when it starts, it might suddenly shoot up. So rather than seeing a gradual start, you might then suddenly see a very, very rapid uptake of vehicle sales, for example. So this is the high level here, up to 100% of vehicles either level 3 or level 4 by 2035. But the lowest one, even the very, very lowest one, we're talking about 5% of level 3 or level 4. So we can extend that out further into time as well. And just to have a few sort of points on here as well, it's more for a UK audience, it's good EU transition over in terms of the UK. We've got the Qatar World Cup coming up in 2021, 2022, the Los Angeles Olympics. All these things seem a long, long way away, but actually in terms of the CAV uptake, we're seeing a very, very changing sort of terrain in terms of how our transport system might be working within these certain events. And then my personal retirement in 2039, that does seem like a long way off still. What we can do, we can sort of overlay some things which might be happening on the transport side of things as well. The development in Dublin, the Cherrywood development, I was with Heinz in 2018, who are the developers for that site, and we're sort of looking at around 2030 when that site might be fully built out. So there's lots of planning going on for these developments now. The master plans are happening, but actually when you put these master plans, when they might be fully built, in the context of what might be happening in the transport system, then even in the second to lowest uptake period, we're still seeing about 30% of vehicles might be level 3 and level 4 combined. So we really need to be planning for these things now in order to get the infrastructure right. Similarly, the longer term Project Island, and there are transport subsets to this as well in 2040. I mean, that's, again, seems like a very, very long way off, and the way that vehicles are going to be moving on the road is going to be quite different. And similarly, the Metro Link 2027. I had getting the taxi from the airport this afternoon. I asked the taxi driver about it, and he said, "Oh, is that going in 2027?" He said, "No, never, no." But hopefully that will be in 2027. But then in terms of the business case, which needs to then move out, if we're talking 30 years from that point in terms of bring the business case together, that's 2057. It's off the scale here, and so, as I said, understanding the impacts of CAV is going to be really, really important to help with these business cases and designing the future of the transport system. Okay, so moving on about the Capri project, that just gives a bit of background to connected autonomous vehicles that I've come across in the project so far. But this is specifically now about the Capri project. The Capri project is an initiative, or it's being funded by an initiative from central government in the UK, who are investing in the testing and development of connected and autonomous vehicles, with the majority of the focus from CCAV's point of view being in autonomous vehicles. There have been a series of funding rounds, probably for the last 5 years or so, where consortia have been able to bid for funding. It's part funding, so it's funded by central government, CCAV, and the consortiums as well, in order to do trials and testing and development, research and development of CAVs. The centre, CCAV, the Centre for Connected Autonomous Vehicles, has been set up, and it's a mixture between the Department for Transport and the industrial side of central government as well. So this is a nice amalgamation of two from DFT Transport, but also recognising that the research and development and the benefit to UK PLC to be able to have the understanding and development and research of CAVs is really, really important. So those two parts of central government policy are coming together to fund some of these initiatives. There's a very, very strong emphasis on collaboration across partners, so they're very much encouraging consortiums to be working together across a whole load of different sectors and areas in terms of bringing academia, industry, SMEs, local authorities, public sector bodies all together, because consider that collective knowledge and understanding is really, really important to be able to develop and move things forward. And more recently, there's been a few physical test beds which have received funding as well. There are 4 of them in the UK, and these are dedicated test facilities to test connected and autonomous vehicles. The Capri project was awarded funding perhaps a year and a half, 2 years ago, and it's one of the largest, if not the largest, CCAV project in terms of consortium members, and there's 19 members, different project partners altogether making up the Capri project. That started in October 2017, and we're due to finish in March 2020. So how did we get here? In terms of the Capri project, we're focusing on pods. We talked about those level 4 vehicles without a steering wheel. You might think, well, how did this vehicle come about in the first place? If any of you have been to Heathrow Airport, there is a dedicated pod, and the Capri pod is based on this exact vehicle design. This is on a guideway, but it's important it's autonomously driven and autonomously controlled as well. So it's taking business passengers from a car park into Terminal 5 at Heathrow, and that's a fully operational system. As I said, it's on a guideway, but it is fully autonomous. And then following then, there have been, outside of the Capri project, the pods were taken into central London in a well-known project called the Gateway Project, and here some trials were done in pedestrianised environments. Principally pedestrian environments were chosen because from a regulatory point of view and from a testing and research point of view, it was easier to get the pods in a pedestrian environment than it was to get them straight on roads. That's why that was happening first of all. And then the Capri project, we're then building on the work and the research that's happened in these previous 2 areas. And rather than just operating in pedestrian areas, we're looking to try and have what's called a dual mode pod. So we're trying to use and develop the pods to be able to use in pedestrian areas, but then also on public roads as well. And importantly, the transition between those 2 different areas. The objectives of the Capri, I've talked about the dual mode pods and the aspect we want them to work in pedestrianised areas and on roads as well. And I think really the goal is to try and see how these pods need to work to be able to work on roads, and that's really where we're looking to implement them and use them. But it's important to have sort of stepping stones along the way in terms of the research and development, hence the need to start in pedestrian areas and then look at the transition and then move on to roads. The key partners in the Capri project working on those side of things, i.e. building the pods, looking at the regulatory side of things, the crashworthiness of the pod and so on, is Westfield Sports Cars, who build and manufacture the pods as well as their own sports cars as well. Heathrow, we talked about Heathrow and the pods being implemented in Heathrow. Heathrow own the IP for the pods and the pod design as well. So they have certainly a stakeholder and a requirement within the project. And then AXA, the insurance company, are heavily involved in this side of things as well. So insuring the pods, making sure that the safety case and things are all acceptable. Importantly, the pods are autonomously controlled. Westfield are developing what's called their ACS, the Autonomous Control System, to be built onto the pod itself. I'll talk about that in a bit more detail in, I think, is the next slide. Other aspects of the Capri project, we're investigating, we talked about the connected side of things and importantly the ride-hailing side of things as well. So we've got a whole work package on the project which is looking at how users might hail a pod, how they might pick one up, the user interaction in order to pick one up, how they maximise using the pod, both hailing it, but then also when they're in the vehicle as well, and that user experience in the vehicle. They've got more time on their hands. How can we improve their user experience once they're in the pod? Connected to that, we're looking at some how we can integrate with the Internet of Things, both uploading data to the IoT, but then also extracting it down as well. How can we make best use of perhaps weather data, traffic congestion data in order to optimize the routes that the pods are taking? There's a fleet management system which is controlling all the various pods. On our project, we're only trialing 4, but looking into the future, say you've got 100 pods altogether, how do you best optimize all those pods in order to pick up the right people at the right time to guarantee their service, but at the same time minimize your own costs as a pod and fleet operator? So 2 key partners there are DINIC and Conidigital. Now, the 4th part is really, really important. We talked about the safety side of things, but it's really important to make sure these pods are tested and verified in different ways. And we've got a very big work package which is looking at that side of things, both in terms of the cyber security of the pod, to make sure no one can, or to research ways in which you can protect the pod from being hacked, for example, or from a cyber security attack, either a physical attack in terms of obscuring the sensors with lasers, for example, but also in terms of the cloud and the data structures which are moving around. And that's mainly principally led by Warwick University and Nexor. There's a big research element in the university side here. Loughborough University looking at some of the physical testing of the pods. So how do we actually test these pods in a physical way to make sure that they're safe and they can operate in the operational design domain that we want them to be working in. And importantly, I'll show you some videos later on, but in terms, we're doing physical testing, but we're also doing what's called virtual testing as well. And this is being able to test the pod in a simulated environment, and we can throw all sorts of different characteristics and things at it in this simulated environment. It allows us to test many, many broad range of scenarios which you couldn't test in real life far quicker and to a far greater extent as well. And last but by no means least, we're looking at the user side of things for these pods as well. So the first 4 parts is quite technology-led, but importantly, it really needs to be user and client-led as well. So what do users and clients want from these kinds of services? So this is more of a softer research side of things to the project, but absolutely no less important as well. And there's a few ESP based in Scotland are leading on that work package, as well as some of our trial locations where we're doing primary research with participants. And the overall aim of the project is really to write the blueprint for what a business case might be for these pod services in the future, and to be able to establish what's required to have a market-ready mobility service from a shuttle and from a pod point of view. And so AECOM's role is to project manage and lead the whole project across all those different areas. We're doing 4 trials over the course of the project. 2 of them are in Bristol, in the West Country in the UK, and 2 of them are in London. The first trial is at Filton Airfield. Now, this is a disused airfield site, and it allows us to do physical testing in a safe way, in such that there's no public vehicles around, so we can do really, really safe testing. We're going to the Mall, which is that'll be our first public trial in Bristol, which is a shopping centre, and we'll be taking passengers from one end outside to the other end. And our next 2 trials are at the Queen Elizabeth Olympic Park in London. In terms of the dates, we've got a busy year coming up in 2019. So May 2019 is our first public trial at the Queen Elizabeth Olympic Park, and then we're going to be at the Mall in Bristol in June, and then our first on-road test is going to be in January next year in 2020. I'll talk briefly about AECOM's role on this with a project lead. Importantly, we're integrating all those different elements I talked about across all those work packages and across those different disciplines, and it gives us an opportunity to really sort of check and challenge and shape all those different work packages, but importantly, make sure that they all come together and we get the best value from them all. We're also looking quite heavily at the exploitation side of things of the project. So this is in terms of the brand for Capri, or how might you sell and create a business case for this kind of service into the future. Okay, so here's our Capri pod which we're using on the trials. And just some key stats here in terms of passenger capacity. They can only take 4 people, which is based on the Heathrow pod. So we're talking about quite, well, a small number of people, but that in theory means that you can be a bit more agile about where it goes and different people that it can pick up and carry around. Maximum speed is about 24 miles per hour. I haven't been on it at 24 miles per hour. It's at the moment, in terms of our public trials and testing, we're going at about 5 miles an hour, something like that. But they are capable of going faster. They've got a reasonably wide turning circle of 13 meters, but with some extra developments to the pod and able to do various turns and things, then that can be reduced. In terms of the sensing on the pod itself and how it's sensing the world around it, there's probably 3 or 4 key sensors which are built on there. The first one is radar. Radars in general is looking forwards, and radar's very good at picking up the speeds of the objects around them. So you get a good understanding of the velocity or the speeds of vehicles either across the path, coming towards you, moving away, and so on. There's something called LiDAR. LiDAR is a lot more accurate, and you get a good understanding, perhaps the classification of objects, and you get a very, very good understanding of exactly where these objects are. So mixing the radar, which gives you speed, and the LiDAR, which is the position, you can blend those 2 different elements together. There's a video on there as well. Video is very good at picking up, for example, the traffic light aspect, the lines of the road, traffic signs and so on, and also some classification as well, so classifying people, young children, older people, and so on. And the key point here is that mixing all of these different sensor sets together is really, really important to get an understanding of the world around it. And it helps with redundancy as well. As one of the sensors isn't terribly good in certain conditions, then there's backup in terms of the other sensors as well. On our pods, there's also ultrasound around the sides. This is a bit more sort of short range, but it can pick up people that are walking close to the pod to be able to know where they are. So those first parts is understanding and knowing, seeing what's in the world around it. It's also important for the pod to know the position that it is on the road. That's generally done through GPS, but there's different levels of that as well. So there's the GPS, something called RTK, real-time kinetic, where you might have base stations around which can then triangulate with the GPS unit to get a lot more accurate. And similarly as well, maybe you've heard with the pods that there is often, or with autonomous vehicles, lots of detailed mappings required, 3D mapping. So the pod might have a reasonable understanding of where it is, but by using the sensors and seeing, there's a sign there, there's a building there, and so on, it can triangulate all these other elements that it's seeing with its own mapping, so it has a very, very good understanding of where it is as well. So that's the final part, is the positioning. We talked about some of the approvals for these pods. Now, this has been a really interesting part of the project, is how do we actually approve these vehicles to be roadworthy and to be allowed on the roads. Principally, there isn't a steering wheel, and some of the vehicle requirements at the moment actually state that the steering wheel needs to be in a certain position in terms of the crash worthiness as well. So these rules and regulations are going to have to be completely changed and rewritten for autonomous vehicles. So over the course of the project, we've been looking at perhaps different methods and routes that vehicle can be moving towards its own vehicle classification. And we think, particularly from a pod point of view, if we can develop a new classification for pods, there are currently standard vehicle classifications, whether it's a bus, a passenger vehicle, a quadricycle, for example, which all those vehicles have to follow. And actually, when you look at them, a pod can't fit within any of them. So we're trying to rewrite the rule book and define a new set of vehicle regulations. But where those regulations will fit in terms of local regulations or global regulations, again, that's something that we're looking at. Different options to us. We can register as a prototype vehicle, for example, which actually would allow us to go out on the road straight away. But in terms of mass sales, then we really need to be getting what's called EC whole vehicle type approval. And this is really very much at the UN level, the global level, which can coordinate all of those standards as well. So there's a whole range between that, and that's something we're working on the project with the regulators to try and define the best way forwards. Okay, the physical testing that we've been doing on the projects are very much based on the trials which we know we're going to be doing. And with those trials, we've looked at the safety concerns, and then we've tried to do testing based on those safety concerns that we've had. I think that's a very important approach to take, in that rather than just doing, oh, we need to do this test and do all these different tests, actually the pod might not be operating in that particular environment. So we've looked at the particular safety concerns and then come up with some tests around that. Here's an example here for the testing at the Mall. We had a concern that there'd be people coming out of concealed areas, for example, and so we developed our own testing environment here. But Heath Robinson sort of person here coming out on a pulley system, but then we can have very controlled tests here. So that person was coming out at different times, different speeds. The pod was approaching at different speeds. We've done a whole range of different tests, not just in that particular scenario, but other scenarios as well, to do physical testing to give us the physical confidence the pod should be doing what we think it should be doing. And that's very much what you call system testing. This is saying we think the pod should respond in this particular way, and then we see if the pod does respond in that way. And that's a good way of doing tests where perhaps the manufacturers are concerned about their IP or their sensors themselves. We're actually testing the system as a whole rather than looking in detail at all the different sensors which they might have IP concerns about. Here's another sort of testing that we've done. Here we had some concerns about the pod making a right turn and being able to, in terms of be able to see different people coming across its path whilst it's making a turn. That was fairly simple, but we've had some different tests and things we've been able to do in that regard as well. I'll talk briefly about the virtual environment. That's the physical testing. It's also really, really important, and this is something that the government and the regulators are looking at in great detail and recognising is something that's going to be really important, is doing testing in a virtual environment. This is effectively taking the autonomous control system, putting it into a computer, simulating the various sensor feeds that might come in from the real world in a simulated environment, to be able to test and see how the autonomous vehicle responds in those ways. And here I've got a video of our Capri simulator in our virtual environments at the Olympic Park. So this might, I'm not sure if any of you are familiar with microsimulation modelling, which might be used from a transport planning point of view to look at congestion impacts and the impacts of different schemes and things. Well, this is a microsimulation model, whereas one of the vehicles that we're modelling is actually responding according to what the autonomous vehicle how they would respond depending on how they see the world. So you can see these two vehicles here are our autonomous vehicle. This looks like a road sweeper. I've tried to get them to update the 3D model, but here we're able to model these things in a 3D environment and be able to test how they respond. And the benefits of this are that you can, with really powerful computing, you can test many different scenarios, and you can tease out what's called the corner cases, perhaps situations where in a physical testing you just wouldn't be able to pick those up. So you can really stress test and really sort of throw as much as you like at the autonomous control system in a safe way to be able to get a really good understanding of does it behave as you'd want it to, and that's going to be part of the regulatory process for the future. There's no doubt about it. That's more from the safety side of things. Also, this could be used to test transport planning impacts as well, of course. So if you have a fleet of pods or a fleet of autonomous vehicles, you can test them in this environment with their responses to see what impact it might have on the road network, how they might be coordinated and managed. I won't go into this in detail. This is our test bench and how the different elements all fit together within our virtual environment. The key bits to pick up here is that different partners, different knowledge and understanding are all feeding at different parts, but it's important to understand this range of scenarios that you want to test, and these are defined here in the yellow box, and then the test bench is set up which can then model those scenarios and then be able to see what the impact is, and then coming out the other side, you know, be able to see, well, based on those results, let's modify some of those scenarios, because I don't think it may have behaved well, but I think if we change it slightly, it might not behave quite so well if we slightly modify those conditions. And this is all automatically done, and there's some AI in there as well in terms of sort of exploring this terrain in order to try and find out what's called those corner cases and tease out where some of the real difficulties might be for these systems. I'll just touch on these briefly. The advisory group on the Capri project is based of experts, regulatory bodies, legal experts and practitioners, and they're really giving us advice on the project as to how we can navigate some of the existing regulatory barriers in order to complete a successful trial 4. This is the pods going on roads. And we're also helping inform from our lessons learned and understanding how we can help inform some of the wider regulatory rollouts that needs to happen. And there's really good knowledge exchange as well. So really focusing on the legal framework for CAVs and the vehicle classification and safety. As part of the project, we've also got an interest group as well, and this is a really interesting group of potential users and clients of autonomous pods. And so we've identified a whole load of site owners, and it's amazing how many people actively want to be part of the Capri interest group. And the kinds of people who are interested are airports, big airport owners, airport operators, developers, universities, local authorities. Universities, mainly sort of campus-based people. I'll come on to that in a bit in terms of how the uptake might happen in terms of different sites. And the purpose of that is, from our point of view, we want to understand, well, where might we need to be targeting, where might these things be used first, and importantly, how they might need to shape the overall design for a Capri and a shuttle service. So as part of this work, working closely with the interest group, and actually we've got some 4 members of the group. We're going to have a very detailed study with them over the course of the next 2 months, and we're developing a business model for a driverless pod shuttle on their different sites. And it's going to be really interesting to look at the different outcomes. We've got some similar sites. We've got 2 airports and we have 2 universities, and being able to compare the differences between those 2 is going to be invaluable. So picking up site requirements, practical constraints, the business case, and looking to implementation opportunities as well. Okay, our trial 4, our on-road trial, just to give you a brief understanding of this, we're looking at the north end of the Queen Elizabeth Olympic Park up here. This section on here is all in the pedestrianised areas of the park, very, very wide footways, so not narrow at all and able to operate well. And then we want the pod to be able to come up here and then operate on roads up near this university building up here, which is a zoom out here. And we're currently looking at different ways in which the pod would need to navigate through this junction here, and this would be a public junction with real life traffic out there. So it's really quite incredible that we're going to be taking an autonomous vehicle, an autonomous pod, going through that vehicle classification process, getting it signed off, and actually running these pods on the public roads in January 2020. But we're looking at different options and different designs for that trial. Part of the project, we're looking at, rather than owners of sites, we're engaging with potential people as well, and understanding their requirements, how they might want to use driverless pods, driverless shuttles in the future. We had a day in Bristol on a Saturday where we had about 80 members of the public all signed up and came along to our scoping session on what's called our co-design event, which is absolutely amazing uptake for a Saturday, but it just shows the level of interest and enthusiasm people had. And we had such a broad spectrum of people coming as well. And some interesting insights coming out from them, principally that they are fewer concerns about the safety side of things, and they are more thinking about the design and how they might want to use these services, different balances between sharing pods with people they didn't know, different conditions, when might they want to do that, when might they not. Some interesting learning coming through that. So the Capri takeaways, the key takeaways that we've got is people are ready and they are talking about embracing autonomous vehicles, and that's an absolute top level thing that's come out from the project, whether it's be site owners, whether it's members of the public, they are fully embracing this thing. Ride sharing with strangers splits opinion, understandably, but then some people are far more optimistic about it than others. So it's interesting to see in what situations might people be more willing to do that. Very, very importantly, the integration of pod services with other modes is really, really important. So how does it interface with existing public transport systems, for example, railway stations, bus stations, other areas? So it's actually an integrated part of the transport system rather than just a solution in its own right. And some of the early applications we're looking at is within sort of constrained operational design areas in terms of airports, hospitals, campus universities and business parks. Okay, preparing for CAVs. I just wanted to, this is a good way, I think, of understanding some of the timescales and some of the case studies which might start first and some of the later ones. And that principally there's two key driving factors for CAVs. The first is the technical complexity of the operational design domain. So by this I mean, is it an easy site for the autonomous vehicle to operate in, or is it very, very complex? And then there's obviously a scale between those two. So easy sites are likely to be quite constrained sites. It might be easy to apply the technology, perhaps not that many people. Interaction with other public vehicles is going to be less. Perhaps the regulatory side of things is a bit easier, all the way to city centre, completely mixed modes, cyclists, pedestrians, HGVs, and so on, up into the other end. So you've got sort of the technical complexity of the solution. And then on the other axis is the business case. So does it make sense for autonomous pods, autonomous vehicles to operate in that way? And two key areas is, the first is, does an existing manual service already exist? Is that service already being provided? Like perhaps through a taxi service, through a bus service? Or actually, does that service not currently exist at the moment? Is there not a current demand for that kind of service or that particular use case? So mixing these two bits together, we can come up with an idea of potential use cases that show up reasonably well. So, reasonably constrained sites where there's existing manual services which work. Vehicle depots, for example, they're off the highway. Buses need to move around at night time for them to be serviced, for them to be cleaned, and so on. That is happening now in terms of these vehicles are being autonomously driven to help reduce the costs and the operations. Port handling and airports, we're seeing more autonomy around airports in terms of airport operation as well. Moving down, still constrained sites, but some of these services don't currently exist from a business case point of view, is perhaps university campuses, campus environments, business parks and hospitals as well. So we see these constrained sites, not terribly complex to operate autonomous vehicles on, but perhaps the business case is a bit harder to make it stack up. The third one is much more challenging site from a technical point of view, but these services do exist currently in terms of public transport, private transport, buses, taxis. And the final one is more the bottom end of the curve, and going back to the initial video, is more wide-scale mobility as a service, people just being able to pop up and pick up a vehicle, it drop them off, the vehicle will go around somewhere else. This is a completely radical situation, as well as in being in an unconstrained site in city centres as well. So this gives an idea of how we might see these services evolve in terms of short term in the top left, short medium term in terms of campus, business parks and hospitals, medium to long term public transport and private transport systems in terms of sort of big rollout, mass rollout, and then finally longer term wide-scale mass and particularly rural services, which are very challenging from a commercial point of view. Okay, I'm just conscious of time, so I think I'll probably skip over these. These can be available online, but it just gives an idea of how you might approach risk in terms of autonomous vehicles and how you might respond to risk and get the investment right. Just some key areas to get involved. I've tried to categorize it into 5 areas. Firstly, monitor what's happening. This is a rapidly changing sector. So in order to understand what's currently happening, you need to be talking to people, monitoring what's happening in the local area, in the national, in the international area, and look at these trends and see how they might be impacting you in terms of the work that you're doing. Engage with people, engage with the researchers, engage with the technology and the applications to understand some of the timescales and what might be happening. Thirdly, implement, so maybe start looking at some trials and testing on your various sites and the work that you're doing, how you can actually start getting some learning from these things, or learning from other implementations that you can see happening. Evaluating those implementations, what can we learn from it, how do we need to change, and then adapt once we've got learnings from that testing. So Maybe it might be adapting the regulatory frameworks or adapting our current approaches to how we're managing the transport system, for example. So, and this is more of a sort of a cyclical process we need to go through. Okay, so finishing off then, where from here? The Capri project, we're focusing heavily at the moment on the actual business case for the autonomous pods, and we're building up to our first public trial in May this year, and May and June this year in London and Bristol. And from an opportunities point of view, we have numerous opportunities in terms of spin-off opportunities outside of the project itself, which we're developing, and trying to advise key clients as well as to how to respond to some of these challenges. Okay, summary and final thoughts then. I said at the very beginning it's been an unexpected journey. Well, it has been an unexpected journey for me in terms of autonomous vehicles, but they are coming, and there's absolutely no doubt about it. Working with 19 project partners is a challenge in itself, there's no doubt about it, but some key lessons that I've learned, and it's sort of outside from the technical side of things, I just wanted to share, is firstly, you've got to innovate and just challenge the norm, and that's certainly what's happening with autonomous vehicles, but even within that sector, it's been really, really important to challenge some of the sort of echo chamber things that can be happening, and ask some quite challenging questions within the industry itself. So try and achieve the best, but at the same time, best is the evil of the good, as I've found many, many times, and actually sometimes you need to knock it down a level just to help things progress and then move forward. We always need to be tailoring approaches, so understanding not just the clients, but the client's client as well. And then finally, but most importantly, we really need to enjoy the work that we're doing with the people and the work that we're doing. And that's one thing I've found working with 19 partners. It's been a real joy working with some of these people, and it's been really good fun. Okay, thank you very much.
All right, thank you very much. I'd just like to open it up now if anyone has any questions from the floor.
Hi, George. Signs and lines seem to be quite important in terms of the mapping and the navigation around. So why do some people think that we won't have them in the future? Where does that train of thought come from?
Yeah, I'm not aware of people saying that directly.
In the video, for example.
Oh, right, yes. Yeah. Well, you probably know my views on the video in terms of how realistic it is. I think in terms of a long-term equilibrium, if you like, for autonomous vehicles, I don't think we're probably going to see 100% cabs on the road network. And the steady states will be some proportion of autonomous vehicles, some proportion of existing manually driven vehicles, perhaps up to level 2 or quite advanced level 2. The reason for that is that people still like to drive, and some people might, in terms of the business cases that come in. So from that point of view, my view is we will still need signs, we'll still need lines on the road as a fail-safe as well. I mean, lots of these systems, if there aren't lines and signs on the road, they're very reliant on the communication and the infrastructure. But still, that would be some kind of fallback. Yes. So in terms of TROs and digital TROs, that's something that's a different stream of work which has been working into. So as well as the digital mapping of the infrastructure, it's almost digital mapping of the rules and the signs and things as well, and bringing all that in. So I think it's the same in Dublin. The TROs normally are handwritten on paper and things, and actually to try and get those in a digital form is an important part for cabs, for them to be able to pick those things up naturally as well.
I wonder, until we have autonomous pedestrians and cyclists, I suspect signs and lines are here for good.
Yes.
I have a question. It's probably not for vehicles or pods that are going 24 miles per hour. So maybe this is more of a future question. And I wonder, has it featured in your thinking as you're going through these trials? Is there a moral question that needs to be, a deeper moral question or argument or debate that has to be had in terms of teaching these autonomous vehicles who to hit, who not to hit? I know that sounds like an odd question, but if I have 4 passengers in my autonomous vehicle and either it's an animal that walks out in front of me or a pedestrian, do we think in the future the machine will be smart enough to say, okay, it's a fox, I'll take the fox and save the passengers? It's probably a deeper question, but does that ever feature in part of the trial that you're developing?
In terms of the Capri work that we're doing, no, we're not looking at the ethical side of things. And I think first thing, it's important to state that the ethical side needs to be completely separated from the technology development as well. So those kind of things need to be done differently. The point you make is the classic, what's called trolley problem. So I don't know if you're familiar with it, but how do you actually make that decision? Some of the conferences I've been to, what people say is actually in those situations the vehicle will just try and come to a stop as fast as it possibly can, and in the same way that when people are manually driving, they will do exactly the same thing. In terms of the Law Commission's recent review, there's a nice quote in there where one of the autonomous vehicle developers was asked a similar sort of question, and their response was, it's assuming that the autonomous vehicle is clever enough and fast enough to be able to make those rapid decisions so quickly in a split second, but stupid enough to be able to get in that position in the first place is sort of a bit of a catch-22 in terms of, and so actually I think in those situations a vehicle will just come to a stop as quickly as it possibly can.
Thank you. Just a question about the connectivity between the vehicles. There are other people developing autonomous vehicles. Is there any kind of conversation had about kind of standardization of the platform which the vehicles are built on, so that different suppliers can talk to each other and connect?
Yeah. Personally, I know less about the standards, but my understanding is from an EU point of view, then those connectivity standards, vehicle to vehicle, vehicle to infrastructure, are being progressed and trying to put into practice. For example, ITSG5 and some of the cellular standards. That tends to be more from the connectivity point of view. From the autonomy point of view, I think it's probably the same thing. So those standards are being developed, and I would have thought will be part of the regulatory sign off of these systems as well. If they're relying on connectivity, then they need to be following those standards. I think the way it will transpire is that the autonomy of the vehicles shouldn't need to have to rely on communicating between vehicles in order for them to work. So they need to be able to operate in their own right, first of all, and the connectivity is sort of an added value, if you like, either from a congestion point of view or from a safety point of view. But that basic level of safety needs to be maintained in its own right, sort of contained within the vehicle itself.
I actually have one question as well. Sorry. Just how are you going to manage the live trials? So, for example, you said you're starting in, say, a shopping centre. Will you have just people monitoring it? Will it be by camera? How are you going to manage the live?
Yeah, well, we have. Importantly for the trials, we have something called a safety case, and that's a very, very detailed document that sets out all the safety processes that we follow in order to do that. The big thing is we have a safety driver within the vehicle who's able to take over at any time, and we have marshals who are dotted around the site. So actually, we're not testing full level 4 with no one around. It's heavily marshalled and heavily managed, but those marshals aren't required in order for the autonomous vehicle to operate. So they're there more to respond rather than to enable it to actually happen.
I think you've answered the question to some extent. It seems to me that use of autonomous pods and so on constrained sites is inevitable.
Mm-hmm.
It's something that will happen. It's an obvious extension of the public transport system.
Yep.
And for linking large car parks to places within a constrained environment. The real problem comes when you start mixing manually driven vehicles in significant numbers,
mm-hmm.
With significant numbers of autonomous vehicles. And in my view, that's an awful long way off.
Yeah.
And I think you were hinting at that at the end. There are a number of issues that I haven't heard much discussion about, which I think are issues relating to what we call autonomous cars rather than
mm-hmm.
pods and so on. One is that where the machine is doing the work, people take their mind off their driving and so forth. and that is likely to be a major issue. It's already happening in certain respects. My daughter drove the wrong way through the Mersey Tunnel because her GPS told her to do that. And I had to explain to her that you're supposed to read the signs as well. Fortunately, there were no other vehicles, no police around.
Right. Wow.
But it shows you the kind of thing that can happen if you rely on technology to sort out the problem.
Yeah.
The other issue that I haven't really figured out is with the trains of connected HGVs, for example. If you're in the middle lane and you want to exit at the next exit of the ramp, how do you get in?
Yes.
These big long train of vehicles.
Yeah.
Does it pick up the fact that you're signaling to go left, or
Yeah. Well, I'm not sure the questions now. I think take the last one first. Mine.
No, it's not directly connected.
Yeah, no, but they're interesting points. In terms of the HGV train, again, I'm not involved in the research and the detail, but my basic understanding is those will work really well in long sections of links where there aren't any junctions nearby. Perhaps when the junctions come up, then those trains would then disperse in order to allow those kind of lane changes to happen. Was my assumption, because you're quite right. Those, or even if you're stuck and then the train is moving, or there's all sorts of difficulties around that. In terms of the first point you made about the constrained sites and things, it seems obvious now talking about it. That's a conclusion, but actually when we started the project, it was we just didn't know, and lots of people are telling us all these things are going to change. Like an obvious application is driverless trams, for example, in terms of the tram system, because that's the existing tram driver doesn't have to do any ticketing as well. So their dedicated role is to drive the vehicle. In the UK, I'm not sure how it's different. When you think about a bus driver, the bus driver also does more than just drive the bus. They are operating the tickets. They might even be cleaning the bus, dealing with any problems, and so on like that. So actually, even the business case for a bus is different to a tram system, because as soon as you take the driver out, you still need to have that basic level of sort of operation outside of just driving the vehicle. So even that's a challenge in itself to make that work.
There was one other thought that just came to my mind in relation to sharing the vehicles, which is kind of implicit in the whole move towards autonomous vehicles, is that you would reduce the number of vehicles, which what that video that you showed was about. But in fact, you will have to find some new status symbol for fellas particularly to have instead of their car, if that's the case.
Yes, yeah. And that's why, again, it's my personal view, but why I think we're not going to go 100% autonomous. The equilibrium will be a mixture between the two.
Thank you.
And we might just take it. Okay, if they're quick, we can take two questions. Sorry.
Good evening, Mark Finnegan. I'm surprisingly from your presentation from Dublin Airport. The type of environment where the things will be future. Heathrow and the IP on the pods. Has there any consideration been given to the use of the pods in the airside environment?
Yes, a fair amount, to be honest, either in terms of transporting passengers from terminal to aircraft, transferring staff, or even just general airside operations, which perhaps don't have passengers on at all, in terms of FOD, foreign object debris and elements. Or outside of, that's airside, but then also landside as well, in terms of an integrated transport system. So I talked about our interest group. We've targeted airports as an interesting use case because of the constrained site. In terms of airside, the regulations they're probably still challenging, but they are less challenging than public road regulations as well. So yeah, there's lots of interest from the aviation side of things on these as an early use case.
Maybe a last question here.
So how do you see the transition panning out? I mean, obviously, these gentlemen said that the time when it's mixed is the most dangerous period. Do you think it'll be like congestion zones like London only for a period where it's just all automated vehicles and no mixing, or do you think they're kind of able to mix from day one?
I think, yeah, often these things won't happen in a click, and already there are trials happening where these things are being tested. I suppose the real test will be at what point does that start scaling up as a commercial service. But I think often these things happen gradually, and so it has less of an impact to actually happen. There's been some talk of autonomous vehicle lanes, for example, dedicated, whether that's dedicated area or just a dedicated lane where that autonomous vehicle would work. Potentially, I mean, motorways is okay. It's very, very high speeds, but potentially that has an earlier use case as well for these things to actually turn into autonomous mode, whether it's a lane or a particular operating condition where they might suddenly be going in that way. I think city centre full autonomy is still some way off, so we're likely to see these early use cases then coming through. The mix between autonomous and manual driving. Some vehicle manufacturers have been designing different colours and things which can flash, which can indicate intentions of autonomous vehicles. I mean, just things like when you're driving, you often look at people in the eye, don't you? And you sort of make gestures, and you can resolve those things. So there's still a lot of research to be done to help resolve some of those.